All right, in this chapter, we're going to discuss inheritance, and inheritance is complicated. I mean, what it involves is not that complicated, but there are a whole bunch of rules you have to know in order to fully understand inheritance. So what I did was to break it up into two parts. So this video is for the first part of inheritance, and then we'll finish our discussion of inheritance with the next video. All right. Now, let me just sort of convey in a very vague way the key idea behind inheritance. Let's say we have a class A and we create a class B. We can indicate that class B inherits everything from class A. So if there is a instance method in class A, that instance method will also be in class B because B is inheriting everything from class A. All right, and then in addition, we can put more stuff in the class B, in which case class B inherits everything from class A, so it has everything that class A has, but it also has extra stuff you can specify as well. You can have additional variables, instance variables, additional um, instance methods. Now, I'm going to make an analogy here. Let's say you have a toolbox that has tools in it, and I ask you, what is that? And you say it's a toolbox, which is the correct answer. Let's say you buy a cheese sandwich and you put the cheese sandwich in the toolbox, and I ask you, what is that? Uh, and if you said, well, it's a toolbox, that would be a correct answer. If you want to be a little more specific, you could say it's a toolbox, but it also has a cheese sandwich in there. Both would be correct, okay? But if you didn't have a cheese sandwich in there, it would be incorrect to say that's a toolbox with a sandwich, with a cheese sandwich. That's the key idea behind inheritance. Uh, and in fact, I sort of emphasized that particular idea that I was just conveying as the fundamental, the golden rule. Yeah, I think I characterized it as the golden rule of inheritance. Okay, and let me state it again. So if you have a if you have a toolbox that has just tools in it, and I ask you what it is, and you say toolbox, that's the correct answer. That's an accurate and correct answer. If you put a cheese sandwich in there, and I ask you what is that box, and you say it's a toolbox, that would be correct. But you also would be correct to say it's a toolbox with a cheese sandwich. Okay, putting a cheese sandwich in a toolbox doesn't suddenly make it not a toolbox. It's just a toolbox with something extra. Okay. So if I point to your toolbox and say this is the toolbox with the cheese sandwich, that would be correct, right? But if you take the cheese sandwich out and I say that's the toolbox with the cheese sandwich, that would not be correct because it's just a toolbox with tools. Okay. Now let's switch back to inheritance in classes. So let's say class B is a subclass of class A. So that means that the class B inherits everything. It gets everything. All the instance variables and the instance method in class A are automatically part of class B because class B is a subclass of class A. And let's say we put some extra methods in class B. Okay. Now, if I point to an object that's created from class B and I say, is that a object? And the answer is yes. It has everything, right? It has everything that's in the A class, right? But it also has something extra. So it's like a toolbox with a cheese sandwich. Toolbox with a cheese sandwich is still a toolbox. So if I point to the object created from the B class, which inherits everything from the A class, so therefore it has everything that's in the A class, I point to that and ask you, is that an A object? The answer would be correct. It's also a B object. But let's say I create something from the A class, right? So it doesn't have the extra stuff that a B object has. And I say, is that an A object? The answer is yes. But if I said, is that a B object, then the answer would be no, because it doesn't have the extra stuff B object has to have. All right, that's it. That's the key idea. Understand that you know, halfway there to thoroughly understanding inheritance. All right. Now, what are the advantages of inheritance? Well, many real world systems form of hierarchy of categories, and you can model that very nicely with classes that are subclasses of other classes. Inheritance, second advantage is that inheritance allows you to, you know, if you're writing the B class and there's an A class already available for you, you can you inherit all that code that's in the A class, so it facilitates sharing code, but it also does something even more significant, is that um, the code that you're sharing, you can in some way modify it, and you don't even have to look at the source code in order to do that. So an inheritance allows the compiled form, you know, the machine language form of classes, to be modified and or extended. And finally, inheritance eliminates the need to duplicate code. Um, and I'll illustrate that with a subsequent slide. Normally, you could do that with regular programming without inheritance. However, it does sort of make it easy, just a sort of a natural thing, that you're not going to duplicate code. So your program is going to still work, but you don't have, you know, the same method repeated in several places in your code. So it's gonna require less space. All right, so here's an example of a hierarchy that you might find in the real world. For example, you know, in a college, you have undergraduate students and you have graduate students. So those are two categories of students. And and you also have professors, right? And students and professors both are college members. So you have this idea of a college member at the top of the hierarchy, and then in that you have two subclasses, student and professor, and within the student uh, class you have two subclasses of that called undergrad and graduate. And you can model that with a program that uses inheritance. You could have a college member class, a student class, which is a subclass of the college member, a professor class, which is a subclass of the college member, an undergrad class, which is a subclass of the student class, and a graduate class that is a subclass of the student class. So you could have five classes, you know, in a subsets type of configuration, as illustrated by this diagram. By the way, when you have a box that represents a class and a box above it that represents another class, and you have an arrow going from the lower one to the upper one, that's how we indicate on these little simple diagrams that the lower one is a subclass of the one above it, to which the arrow is pointing. Okay, so that's what those arrows indicate there. For example, the arrow going from student to college member indicates that student, that box represents a class that's a subclass of the college member class. Now, let's say, you know, for all these five categories, you want to know what what the telephone number is. Okay. So you could put in college member, a method that will just return the phone number of that member of the college. Okay, and so you would have you know, a instance variable with the phone member, uh, and that method, you know, that would return the phone number would be inherited by student, and and therefore it would also be inherited by undergrad and grad. It would also be inherited by professor. So let's say you're working with the graduate class. If you want to know the phone number of a particular graduate student, you just invoke that method that's inherited. You don't have to have a separate, return phone number method in each one of these classes. You just put it at the top of the hierarchy, and then it gets inherited by everything below it. So everything below it has access to that one, rather than having, something that returns the phone number in each one of these things. You just put it at the top of the hierarchy, right? So that's what I was talking about when I said it facilitates. It makes it easy not to have redundant code, right? You just put something, if you're going to have something that's used by all these classes, you just put it at the top of the hierarchy. And then all of the classes inherit it, so you don't have to repeat that same method over and over and over again in all the classes in the hierarchy. All right, so here is a simple example. And this is Class A, and I'm going to show Class B. Class B is a subclass of Class A. And equivalently, we could say A is a superclass of Class B. It says the same thing. B is a subclass of Class A, or A is a superclass of Class B. So when I say A is a superclass of Class B, that means B is a subclass of Class A. All right, and this is a pretty simple class. It has an instance method X, which is private, as data normally is in a class. And it has two public instance methods. One is getX, that just returns the value of X, so it's going to return 1. And one that called toString, that is going to return the value of the instance variable in string form. And that's what line 12 is going to do. You have that string constant x equals, right? And therefore the plus sign means concatenation, not addition. And so the value, which is going to be 1 in the variable x, is going to be converted. A copy of it will be converted to the string that contains digit 1. And then you're going to concatenate the two together, x equals and the string 1, to get a string x equals 1, which then is returned to whoever is calling toString. All right, so we have two different kinds of things. GetX is just returning its value, and toString returns the value in string form. And in this case, we also are prefixing the string that's being returned with a label identifying what it is, x equals. Now, you don't have to do that. For example, if I just wanted to return the value 1 in string form, and I showed this to you in a previous video, what you do is you need to convert the value to string. All right. So what you do is you just take everything out between those two quotes. Take it all out and just have two quotes right next to each other. That's the null string. But nevertheless, it's a string. It's a valid string. It doesn't contain any characters. Its length is 0. And so that's going to trigger, the plus then, because you have a string on the left. The plus will mean concatenation. So a copy of 1, a copy of the value in x, which is 1, will be converted to the string 1 and concatenated with the null string, in which case you just get the string that contains 1. All right, so if you just wanted to return the value in string form, that's the way you do it. You just concatenate it with the null string. But here I'm doing something a little fancier. I'm concatenating it with the label and then returning that whole thing, x equals 1. All right, so I already mentioned this. When you have these boxes that represent a class, and you want to show that one class is a subclass of another class, you just put the two boxes, with the superclass above, the subclass below, and have an arrow pointing up. Right? So that means B is a subclass. And the way you make B a subclass of A is at the very beginning to have class B extends A. All right, so if we create a class A, an object from the class A, we're going to get the three things in it. X, that instance variable X, XGet that returns the value as an int, and then toString that returns in string form what's in X, but it precedes it with a label X equals. All right, that's what we get if we create something from class A. Now, if we create an object from class B and assign it to the pointer B, this is what we're going to get. We're going to get, first of all, we're going to get everything that's in class A, right? So we're going to get an X, we're going to get an XGet, and we're going to get a toString method. We're going to get those two methods, which are identical to the two methods in the A object. And we're also going to get, the X variable that also is in the A object. And it's going to be initialized to 1. Okay. But we also get everything, gets stuff extra that we defined in the B class. If you look back at the previous slide, you'll see that we had a Y instance variable and we had a Y get method, neither of which was inherited. But we also have a toString method, that was specified in the B class. So the B object, therefore, is going to have one X variable, one XGet, one Y variable, one YGet, but it will have two string methods. It will have two string methods, the one that's inherited and the one that's defined in the B class. So let's say you want to invoke toString using B, and you said b.toString left parentheses, right parentheses. So which one are you going to inherit? Well, you inherit the one that you defined in B. And we say that the one that is in B overrides, that's the technical term, overrides the inherited one. And the reason why it overrides it is because, number one, it has the same name. Both of them are the same name. And both of them, if you look at the definitions of both of them in the previous slides, both of them have the same parameter list. Both of them don't have any parameters. Right? Now, if let's say the one that you defined in B had one parameter for some reason, and the one that you inherited didn't have any parameters, then you wouldn't have overriding take place. If that were the case, if you said b dot toString parentheses some number, let's say 8, then that would necessarily invoke the one that has one parameter. However, if you said b dot toString parentheses with nothing inside, then that necessarily would invoke the toString in your B object that had no parameters. All right. So if they're distinguished by their parameters in terms of order, number, or type, then you don't have overriding. You have overloading. The toString method would be overloaded, and which one you call will depend on the arguments you use. The compiler will just translate the call to the one that has a parameter list which is consistent with the arguments that you're passing it in the call. All right, so that's an important concept. You can override methods that are inherited, and sometimes you want to do that, right? You might have an object, like a class like A, that has all kinds of stuff in it that you want to use, but there's one method in there that you really don't want to use. You have to you need a special purpose one. You can't use the one that you're inherited. So you just define that one method, okay? And that one will override the inherited one. But you can still use, for example, in a B object, I can say B dot get X, right? Because I have a get X method. Okay. I can say B dot get Y because I have a Y get. I have an X get, I have a Y get. So I can call both of those because both of them are in there. All right, let's continue. Yeah, here are some statements. So here I am creating a new A object using the new operator, followed by the followed by the class name parentheses. And what I'm doing there is actually calling the A constructor. So after the new will create the object, and then the A constructor, typically constructors will initialize the object, and that whole thing on the right hand side of the equal side returns a pointer to the object, the A object, which is then assigned to A. And if you're creating a class A object, the pointer should be of type A, right? So I have cap A, little a. That little a should have type cap A because I want it to point to an A object. Now, if you look back at the A class, there was no constructor there, but remember, I might have said this. I seem to recall I already said this. If probably I didn't say it. If a class doesn't have a constructor, the compiler will insert one automatically in the translated code. So it's not going to change your source code, your actual Java code, but it will insert one in there. So you'll always have, whether you include a constructor in a class or not, you'll necessarily have at least one. Okay. And if you don't have any, you get this one that's automatically inserted. It's called the default constructor. Now, if you do include a constructor that yourself explicitly put one in there, then you won't get the default constructor. You only get the default constructor if the class doesn't have any in there already. The source code doesn't specify a constructor. So what we're doing is we're calling xget, and it's going to return 1. And since it's a print line, you'll see 1 on the screen. And if you say a.toString, that's going to return the string x equals 2. No, x equals 1, right? And that will be displayed. Now here we, on the next group, we are creating a B object. So we say new B, and we're invoking the B constructor. By the way, there is no B constructor, I believe, in this example. But so you're invoking the default constructor. Okay. So anyway, that whole right-hand side returns a pointer to the B object that's created as a result of the new operator, and then that's assigned to the little b variable. That little b variable is a pointer that's supposed to point to B objects. All right, it's supposed to point to B objects. And therefore its type should be cap B. So B has type cap, little b has type cap B. All right. And then if we say b.yget, it's going to return the value in y. So I think that was 2. And then b.xget, it's going to return the value in x, right? Xget and x are inherited. So it will return the value in x, which is 1. And then if you say b.toString, it's going to, you got two string methods, but it will execute the one that's defined in the B class, because that one will override the inherited one. And notice that the names are identical, right? And you have the same, the arguments are the same. You have a null argument list, which means that, suggests that the definitions of the two string methods have the same parameter list. They don't have any parameters at all. So they you have overriding taking place rather than overloading. All right, now this B object inherits everything right? It inherits everything in the A class, right? So it inherits X and XGet, and it inherits the toString that's defined in the A class. So it has everything that an A object, that it has, this B object that we're creating has everything that is in an A object, right? Because it inherits everything from the A class. So would it be correct to say that this object that B is pointing to is an A object? Yeah, it's an A object that has something extra in it. Okay, it would be completely correct to say this B object is an A object because it has everything an A object has. And why? Because it inherits everything from the A class. So obviously it's going to have everything that an A object would have, except this B object has something extra. Okay. Now, would it be correct to say the A object that's created at the very beginning of this slide, the one to which A is pointing, is an A object? Yeah, it's an A object. It's created from the A class. But would it be correct to say it's a B object? No, because it doesn't have that extra stuff. It doesn't have the YGet. It doesn't have the Y variable. It doesn't have that toString method that is unique to the B class, right? So it wouldn't be correct to say the object to which the little a is pointing is a B object, but it would be correct to say that the object to which little b is pointing is an A object as well as a B object. It's both. All right, that's the key idea. That's the golden rule of inheritance. Understand what I just said. All right. All right, now here's something you should understand about constructors. Every class has at least one constructor. You could include in a class, 5 different instructors. You could overload them. By the way, constructor, as you know, has to have a name identical to the class name. So if you have 5 constructors in a class, they're all going to have exactly the same name. So they have to be distinguished by their parameter list. The parameter list each one has to be distinguished from the others in terms of order, number, of type of parameters. So that's perfectly okay. If you don't code any constructors, then when it's translated by the compiler, the Java compiler, the compiler will automatically insert a constructor, which is called the default constructor. All right. Now, I think I might have said, I'm pretty sure I talked about constructors before. Anyway, and when I was talking about it, I say, well, the default constructor does nothing. And I might have also said, but that's not quite true. We have to, learn more before we can know exactly what a default constructor does. A default constructor does something. It calls the superclass. All right? So it will do something. It will call the constructor in the superclass. Will the superclass have a constructor? Yes, necessarily it will have a constructor. Why? Because every class has to have at least one. So if, let's say, class B doesn't have any constructors at all, you didn't include any when you wrote the class B, the default constructor that's automatically inserted into the machine code for that class will include the default constructor, and it will do one thing. It will call the constructor in the superclass, and the superclass has to have one as well. All right. Okay. All right. So here we have class A, and there we have an explicit constructor, x equals 1. And then we have an instance method. There I'm using private, right? Private int x. So x is an instance variable, but it's private. You can only access it from within the class. However, you can call xDisplay, which is public, which can access the variable x because xDisplay and x are in the same class. All right. Now, if you recall the previous slide, every constructor calls the superclass. So before you do x is assigned 1, that constructor is necessarily going to call its superclass. All right, so, but there's nothing there preceding. All right, and what's the super? A doesn't have a superclass. All right, well, actually, both of those statements are false. If you just say class A, you just specify class and the name of the class, and that's it, like I'm doing here, um, it will automatically uh, be treated as if it's the subclass of a class called the object class. So the object class, if you do what we're doing here at class A, the object class will necessarily be its superclass. Okay? And of course, if you say class A, or let's say class B extends class A, class B, class B extends A, then 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 class B obviously has an explicit superclass that you explicitly specify at the beginning of class B. But if you don't specify a superclass, you get one automatically. So every class has a superclass. And what will happen is that when the compiler translates this constructor, public A, print that constructor that initializes x to 1, it will insert code there automatically. You don't see any code preceding x equals 1. So it will insert code automatically to invoke the superclass constructor, the constructor in the superclass. So that's what's going to happen. We're going to actually have at the very beginning of the execution of A, the call of the constructor in the superclass of A. All right. And that superclass in this case, is going to be the object class. And you don't create the object class. That's something that's already existing. All right. It already exists. Okay. So this is class A, and now, now here we have the definition of class B, which is a superclass of the A class, and it has two constructors. One, the first one that starts on line 20, just always initializes the instance variable to 2. The second one that starts on line 25, when it is invoked, some value is passed, which is automatically assigned to YY, which is then used to initialize Y on line 28. So that's a more versatile one. But if you just want to, just say when you say new B in just parentheses, then you'll get the default 2 initialization. But if you say new B parentheses 5, then Y receives 5, and then 5 is assigned to Y. All right. Now, what's line 27? Line 27, super, is a call of the constructor in the superclass. So that's how you do it. If you want to call the constructor in the superclass, you say super, left parentheses, right parentheses. Now, let's say the only constructor in the superclass has one parameter of type int. Then here in the subclass 27, you should say 27 left parentheses, right parentheses. You must have an integer number inside those parentheses. Otherwise, this super is not going to be compatible with the super within the constructor in the superclass if the only one that's there has a single parameter. If you have a single parameter, the call has to have a single argument, right? The arguments have to match the parameters. So here we have no arguments. There has to be in the superclass constructor a constructor that has no parameters, or no constructors, in which case it gets the default constructor, which is a constructor that has no no parameters. So that would work with line 27 if you had just a default. Now in line 22, we have the statement that initializes Y, and there's nothing that precedes it in that constructor. However, as I mentioned, every constructor calls the constructor in this superclass. So when the compiler compiles this, it will insert super, left parentheses, right parentheses, at the very beginning of that constructor. All right, so both constructors, the very first thing they will do, all constructors, the very first thing they do will call the superconstructor. And since you're inserting just before line 22 super, that's what the compiler will do. There better be in the superclass a constructor that doesn't have any parameters. Otherwise, this call is not going to be consistent with the constructor in the superclass, and it's not going to work. Now here is the last part of the program that we've been looking at. It contains the class C, which extends B. So we have a hierarchy here. C is a subclass of B is a subclass of A, and A is a subclass of object. Okay, and this class has a Z variable, and it has this XYZ display method. And what it will do is it will call XY display in the B class, which will display X and Y, and then it will display Z equals whatever Z equals. So if you look at the main method, you'll see that if we have a B object and we call XY display, you get out X equals 1, Y equals 2. If we then on line 55 create a B object but pass it 3, all right, so 3 in that case, there's a constructor will take that argument, will receive that argument and take that value and initialize Y with that. So that constructor on line 53, we're just using the constructor that always initializes Y to 2. But the constructor, the other constructor, which is going to be invoked on line 55, initializes Y, will have the effect of initializing Y with 3. So the next call on line 56 of XY display will display X equals 1, Y equals 3. And then finally we create a C object, and it will display all 3, X equals 1, X equals, Y equals 2, Z equals 4. Yeah, Z equals 4, right. All right, so now I'm going to get back to this little analogy about a toolbox and a toolbox with a cheese sandwich. So if you look at this code, little a initially is going to be assigned a pointer to an A object, okay, and B will initially point to a B object. All right. All right, so let's look at the second sequence. So we have A pointing to an A job, but look at the second sequence. There we have an A object, right? Oh, excuse me. We're declaring A to be type A, and we're declaring B to be type B, and B is pointing to a B object. And then we have this assignment statement. A is assigned B, and when you execute that statement, B is pointing to a B object. So if you take that pointer that's in the B box and put it in the A box, then you'll have the A box doing the same thing the B box does, and that is pointing down to the B object. Now, the little a thing has type A, so it should point to an A object. Is it the B object an A object? It is, because B in this example is a subclass of A. So that B object has everything an A object has to have. So it's perfectly legal for that A pointer, even though its type isn't cap B, it's cap A, it's perfectly legal to have it point down to that B object. All right? So the B object is like a toolbox with a cheese sandwich. So A is supposed to point to toolboxes, and so it's perfectly okay for A to point to a B object because it's a toolbox. It just has something extra in it. It has a cheese sandwich. However, it would be illegal for if, let's say, there was an A object that was created from the A class. It would be illegal for B to point up to an A object. All right, it would be illegal because B is supposed to point to an object that has everything in A and everything in the B class. It has everything in both those classes, but and therefore it would be illegal for that B variable to point, that little B variable to point up to an A object which had just the stuff that's in the A class. So the rule here, and this is the exact statement of the golden rule of inheritance, is that a pointer can point down to an object at a lower level in the class hierarchy, but a pointer cannot point, and it can point across, like B is pointing across, same level. And A is at a higher level, right? A is defined to be, an A pointer, and A is a superclass of B, so we think of that as a higher level. So the A can point to a object that's strictly A, but it can also point down to a B object. So pointers can point across like little b and point down, but they cannot point up. And when I teach this, I tell this silly thing about, when I'm in New York City, I'm a little on guard because, I don't live there, and I don't know, I think maybe someone might try to hustle me. So, and if someone might say, hey, look up there at the sky, there's something, I'm going to be a little reluctant to look up because I think that makes you very vulnerable. But if he says, oh, look at that sign there, I probably would look at that sign, like, if I'm driving a car and he's pointing out, hey, you're going the wrong way in a one-way street. Or if he said, hey, look at the ground there, that's easy to do also and still sort of see what's around you. But it's saying looking up. So that's sort of a stupid way to remember that pointers can point down in a hierarchy or across, but can't point up. All right, so here we have A, which is pointing to a genuine A object. And then and B is little b is a B object pointer, right? And there I'm trying to take the pointer that's in A and put it in B, right? In which case B would point up to the A object. If I make a copy of that address, pointers are addresses. So this object is, let's say, at location 1,000, all right? So you would have 1,000 in A. So it's pointing to that chunk of memory at location 1,000. If you take that 1,000 and copy it into B, then B has 1,000 in it. So B would be pointing to that same position in memory, which would have the object A in it. But that's illegal because B is supposed to point to B objects, and that A object isn't a B object because it doesn't have anything that came from the B class. It has a B object has to have everything that inherits from A, but it also has to have the stuff that's defined in the B class. It doesn't have the stuff that's defined in the B class. So that's illegal. Now, if you look at the bottom of this slide, I am using a cast. So I am taking that pointer and I am casting it to B. If you do that, it will compile okay, but then it won't run because a B pointer cannot point up, right? So even with a cast, it's illegal. You can't have a pointer pointing up in the hierarchy. It can point across or down, but it cannot point up. All right, now here we have a case where we have an assignment statement. If you look down at the bottom there, we have B2 equals A, and then B2 equals the cast A. Now, just immediately you would say, well, that's illegal because A is at the A level and those B1, B2 are at the B level. So if you were to execute either one of those assignment statements at the bottom, B2 equals A, you're getting B2 to point up to an A object. Okay. And indeed, that first one is illegal, but believe it or not, that second one is okay. That second one is perfectly legal, assuming what happens, as described here, does happen. So let's see. We have a object. We have an A pointer. Little a is a little A pointer, and we have the two B1, B2, which are B pointers. Okay, the B1 points to a B object, right? And then we take that B1 object and put it in the little A pointer. So A is pointing down to a B object. That's legal, right? You can point down. Now, if we execute the statement B2 equals A, the one that's marked illegal question mark, it is illegal. The compiler is going to see that, and it's going to say, well, A is going to assume that A is pointing to an A object, a regular A object that has in it just the stuff that's in class A. And B2 is a B pointer. It's supposed to point to B objects. And so it won't like that because um, if A is pointing to something that's strictly an A object, B2 should not be pointing to it. But in fact, A in this case is in fact pointing to a genuine B object because it's pointing down. So if you do the cast, okay, if you do the cast there, if you cast A down to B using that cap B cast there, it will compile correctly, and then at execution time it will work because you're actually assigning a pointer to a B object to B2, which is supposed to point to B objects. All right. So let me state this thing very simply. By the way, when you do something like we did there at the first group, A is assigned B1. What we're doing is we're taking that pointer and moving it up in the hierarchy. You know, that pointer is a B level pointer, but we're moving it up and putting it in little a, which is at the A level, the higher level. So we refer to that as upcasting. We're upcasting the pointer in B1 and putting it in A. Okay. Now, if you do the reverse, if let's say you have a pointer that's pointing to an A object, an actual A object, and attempt to assign it to B, where B is a pointer to a B object, you're taking that pointer and you're trying to move the tail end of it down in the hierarchy, and we call that downcasting. Okay, so downcasting is normally illegal, and when the compiler sees the first statement that's marked illegal at the bottom of this slide, B2 equals A, it knows that A has type cap A and B2 has type cap B, and it knows that A, right, that A is higher in the hierarchy, so that's a downcast, and so it's gonna be flagged as illegal. But in this example, it's not really a downcast because it was previously upcast. Okay, the A is assigned B1 is an upcast. So you have this B pointer, it's an upcast. So it is actually okay to downcast it because it was previously upcast. If you take the tail end and move it up, right, so it's pointing down, that's legal. And if you then downcast it, it would then just be pointing across. And both of those configurations would be legal. So it's okay to downcast as long as you previously upcast, because then it will not be pointing up, it will just be pointing across. Now the compiler doesn't know what happened, so it will, that first statement that's marked illegal, B2 is assigned A, it's assumed that's going to be illegal. But if you do the explicit downcast, which in this case is legal because of the previous upclass, then it will compile okay, and it won't cause a problem at runtime because the pointer that you're assigning to B2 is actually a pointer that's pointing to a B object. All right, a lot of words for a pretty simple concept. You can't downcast a pointer unless it was previously upcast. Let's say you have a pointer which is pointing to something at its own level. So we say it's pointing across. It's not pointing up, it's not pointing down. And then you upcast it. That means it's going to be pointing down as a result. So if you then take that pointer which you have upcast, if you downcast it as a result of the upcast followed by the downcast, the resulting pointer will be pointing across, which is perfectly legal. However, you cannot, if the pointer is that you actually start with is pointing across and you downcast it, then that would mean it would end up pointing up to the next higher level, which is illegal. So normally you can't downcast. However, if you first upcast, then you can downcast because the downcast doesn't result in a pointer pointing up. If you first upcast, then it will be pointing down. Then when you downcast, it will be pointing across. Okay, and that's what we're doing here in this first example. We are creating a B object, so B1 is pointing to a B object. Then the next assignment statement, A is assigned B1, that's an upcast. We're putting a B object pointer in A, which is a higher level, so A is pointing down to the B level. And then A is assigned to B2 is a downcast, which is legal, right? It is legal in this case because A actually is pointing to a B pointer, so there is, there's no prohibition in assigning a B pointer to B2, which is supposed to point to B objects. However, we do need that cast. If you don't need that cast, the compiler will assume that A is pointing to an A object, a regular A object that's not also a B object. And therefore the assignment statement B2 is assigned to A. Okay, B2 is assigned A. Um, the compiler is not gonna flag that because if the assignment statement B2 assigned A is gonna, from the compiler's point of view, is a downcast. You have A pointing to a object, and if you assign it to B2, that means B2 is going to be pointing up to the A level. However, A, in fact, in this example, is actually pointing to something at the B level. So the cast is legal and the assignment statement is legal. Now you can check to see if something is pointing down. For example, here we have at the bottom example, we have little b declared to be a B pointer, a B object pointer. And if I want to know if I can downcast A, which is what the statement does, B is assigned, parentheses around the cap BA. That's a downcast. If I want to make sure that that's legal, I can check with the instance of operator I can check to see if, with the instance of operator, if A in fact is actually pointing to a B object. So if that true-false expression is true, that means A is actually pointing to a B object. It is actually pointing down. So then the downcast would be legal. All right, here's a little case study. We have class A. It has two instance methods. And the F1 just says F and A, and the G1 just says F and G. So when you invoke these things, A here refers to the class that contain them. So when you see coming out, this is just the first part of the program. Anyway, when you run this program, if you see coming out G in A, that means you executed the method that starts on line 8 here. If you see F in A come out, that means you executed this F function that starts on line 3. All right. So I just put those print lines in there. So it's very easy when you look at your output, you know which method is being executed. So we have a F and G function. Okay. And then we have B, which is a superclass that extends A, which has a G. I said function. I should have said G method. Remember, sometimes I say function rather than method. So anyway, we have two methods. And in this one, we have two methods. We have a G method and we have an H method. So when we create a B object, it's going to have an inherited G, and it's going to have one that's defined here on line 16. All right. It will have exactly one F method, and it will have two G methods, and it will have one H method. It has two G methods because there's one in the B class and one in the A class that gets inherited. All right, so that's what's in a B object. One F method, two G methods, and one H method. All right, and then here we have the main method that's going to create a B object, and then we do a upcast, right? That's an upcast on line 33. We have a pointer which pointing to a B, and we're moving the tail end in a sense up to that A variable, little A variable. So the A is going to be pointing down to the B object. And then we say A dot F. We get F and A, obviously, right? A is pointing to A is pointing down to a B object, right? Because of the upcast. So if you say A dot F, it's gonna execute the F method in the A class. Why? That's the only one in the B object, the inherited one. There isn't one defined at the B level. But if you say A dot G, it's going to execute the one in the B class, right? It's going to display G in B. It's going to display the one in the G object. Why? Because that one is going to override the inherited one. You have two G methods. The one in the subclass overrides that one. And then here we have A dot H. All right. Now that's illegal, right? That is illegal. Now why is that? Well, H is something that is in the B class, but not in the A class, all right? So when the compiler sees that, line 36, it says, well, A is an A pointer. It's supposed to point to A objects, so an A object doesn't have any H method. So it will flag it as illegal. It doesn't realize that A is actually pointing down to a B object. It will give you a compile time error message. But then on line 37, what I am doing is I am taking A and I'm casting it down to the B level, right? So that whole thing there in parentheses, that group of parentheses there, is a pointer that is at the B level, which then will successfully work with the method H. So you get out H in B. And then, of course, if you use B, B is pointing to the same B object, so you'll get out H and B. All right, so that's an interesting example. By the way, all these are in your software package, so you can play around with them, which is a good way to, sort of really get into the material and understand it more fully. Right, yeah, here's a picture. You have A and B pointing to this B object. You have two G ones, right, in the B object, and the one in the inherited one is overridden by the one that's defined at the B level. All right, now, as I already mentioned this, but let's repeat what I said. This has some useful slides. If you say class A, like the thing on the top of this slide, uh, or if you say class A extends object, same effect. So if you omit extends object, it will be assumed and it will be translated. Class A will be translated as if it's the subclass of this object class. All right. And this object class is available. It's not something you create. It's going to be available to you. So anytime you do class A, it's going to inherit everything. If you do class A or class A extends object, by the way, that's a capital O there. Capital O and then lowercase b, j, e, c, t. If you do either one of these, your A is going to be a subclass of object, and it's going to inherit, therefore, everything in object, right? So class A will have everything in object. Now, if you have a subclass B, if you have a class B, which is a subclass of A, then it's going to inherit everything in A, which includes the thing it inherits in from object, right? So if B is a subclass of A and A is a subclass of object, B will have not only everything in the class A, but will have everything in class A that came from the object class, all right? So the fact is, every class, every object you can create will have whatever is in the object class, right? Let's say the object class has this toString method. That means every class, your class A, subclass B, subclass C, all the classes you could make will have a two-string method in it. All right? Every one will have it because whatever A inherits, the substring of A will inherit from A. All right? So if two-string is in object, it will be in A. And then if you have B, a subclass of A, it will be in B, and so on and so forth. Yeah, so we have the object class, and then we have class A, class B. So this class is going to have everything in class A plus everything in object. So class A has stuff that's defined in class A, and it inherits everything in the object class. Then class B is going to inherit everything in class A, which includes everything class A inherited from class B, from the class object. Okay. All right. So here we have an example here. We have class A and class B, which is subclass of class A, and they both have some instance variable, which is private. No two-string method, but notice when you create a class A object, it's going to inherit from the object class the two-string method that's in the object class. The object class has a two-string method. So A, which is going to be a subclass of the object class, is going to inherit it. And then B is going to inherit the two-string object that's in the A object, right? That's in the A class. All right. So if you create either a class A or class B object, there will be a two-string method that comes from the two-string method in the object class. By the way, in the object class, you also have an equals method. So if you look at that first comment there, class A is going to inherit everything in the object class. And the object class has a two-string method. It also has an equals method. Okay? So any A object is going to have both those methods. And any B object is going to have both those methods as well, because it will inherit them from A, and A inherits them from object. All right, so now I'm going to actually invoke those two-string and equal methods. So I am, let's see, on 15, I'm creating two A pointers, A1 and A2, and I'm creating two A objects. They're going to be identical, by the way. So A1 is pointing to an object, A2 is pointing to an identical A object. And now I want to display what's in there. So I say system.out.println A1.toString. So it should return the value of the instance variable in string form. And I think it was 1. I think it was 1, something like that. It was 1. But I get out some weird thing there, which is shown in the comment. Capital A at 3E25A5. What the heck is that? And then on line 19, I use the equals method that's inherited from object to compare A1 and A2. All right, and see if they're equal. They are equal. A1 and A2 are pointing to identical A objects, and it returns false. So that's not true. That's not correct. It should return true. And 18 should return the value. I think it was 1. The value of that instance variable in that object, and instead it returns this weird thing. And you know what I think that is? I think that starts with the class name, right? So the two-string method in the A object is going to return a string that consists of the class name, the @ sign, and then that weird thing, 3E25A1. You know what that is? I think that's the address of the object in memory. And you say, well, that can't be, because what's E? You know, that's not a digit. Well, actually it is in the numbering system that's called hexadecimal. Now, binary has 2 symbols. Decimal has 10 symbols, 0 through 9. Hexadecimal has 16 symbols. It's base 10, right? It has 16 symbols. And the weights go up. They start from 1, then 16, and then 16 square. So it's the same kind of system, except it uses 16 rather than 10 as in binary, or 2 as in 10 in decimal, or 2 in binary. And so you need, for hexadecimal numbers, you need 16 distinct symbols. So hexadecimal, typically the 16 symbols are 0 through 9, right? You use the same 10 that you use, but you need 6 more symbols because you need a total of 16. So what hexadecimal numbers typically use for those additional 6 symbols is the letters A, B, C, D, E, F. So this actually is a hexadecimal number, and I believe that's the address of the object, the A1 object, in memory. All right. Now what about line 19? It returns false. Well, the equals method here doesn't check, doesn't compare the two objects. It compares the 2 pointers to the 2 objects. So it's checking to see if the address in A1 is the same as the address in A2. Now those addresses are different because they're pointing to different objects, so those 2 addresses are different, so it returns false. So A1 dot equals parentheses A2 would be equivalent to saying A1 equal A2. You're just checking to see if the 2 addresses are equal. All right, now we do the same thing with the subclass of A, right? And the subclass B, which is subclass of A, will also have a toString and an equals method, and we create 2 identical B objects pointed to by B1 and B2, and then I use the toString, and then I would use equal. I get out the same kind of result. I get out false. Why? For line 25, because it's just checking the 2 addresses, which are not equal, so it's going to be false. And for line 24, it displays the name of the class, @ and then some weird hexadecimal number, which is just the address in memory, the hexadecimal address in memory, where the B object is sitting. By the way, hexadecimal, let me just digress for a second. Hexadecimal is frequently used when you're really getting into the innards of computers. You know, when you get to the low level of programming. The reason why it's used is because, as you know, what's really inside the computer are all binary numbers. All right. Now, if, let's say, you see something in memory, you actually see the number in there using some kind of program. You may want to know what the decimal equivalent is, and it's a difficult process to convert binary to decimal. Also, let's say either way, if you want to have a binary number, you want to convert it to decimal, or decimal to binary, either conversion is difficult to do. And so a lot of times, you're getting some results to display in decimal, but you want to know what those values actually look like in memory, and they're in binary, of course, when they're actually in memory. So what you have to do would to take the decimal number, convert it to binary. It's not easy to do. However, if something is written in hexadecimal, there's a very, very easy procedure to convert it to binary. So that's a hexadecimal number there. Let's look at that first one, on line 18, right? That's a hexadecimal number. I can convert it very easily. I don't need a pencil and paper. I'll tell you what that number is, that hexadecimal number is in binary. It's 0, 0, 1, 1. 1 1 1 0 0 0 1 0 0 1 0 1 1 0 1 0 0 1 0 1. It's that long binary number. You see, I just converted it, and it's easy as pie to do the conversion if you know how to do it. I didn't have to memorize a whole lot of stuff. You do have to memorize few little things. Very easy to memorize. In fact, if you just work with this stuff for a while, you just automatically memorize it. And so I could do the conversion. So that's why hexadecimal is used a lot. Normally, the third course you take, you do programming at a much lower level, and you'll probably at that point learn all about hexadecimal numbers. Okay. So anyway, by the way, why does the two string not work correctly? I understand why the equals doesn't work, but in fact, well, why is the thing? Why doesn't the equals method you inherit the correct equals method that will that will compare the objects rather than compare just the pointers to the objects? So I think you could ask a very good question for both toString and equals as it is defined in the object class. They weren't defined correctly, right? Tostring should display the instance data in the object, and equals should compare the objects, not the pointers to the objects, right? Those are two good questions to ask, because it would be impossible to have a toString and an equals method in the object class that would work for every possible object, right? So how like let's say you have a object that has three instance variables x, y, and z. So the toString method should display all three. And then maybe you have another one that has 100 instance variables, and then maybe another that has one. How could you have a single toString that would work correctly for all of them? You could have one that would display just one, but then it wouldn't work for those that have more than one, or have a different name for that object. So it would be impossible to have sort of a generic toString and an equals method defined in the object class that would work for every possible object. So even though they're inherited, they're really no good. You never would want to use those. So that leads me to another interesting question, and you probably are thinking of it right now. All right. So we have these two methods, toString and equals in the object class. And they're inherited by every class, every object that you create. They're going to, in every class, they're inherited. So every object you create are going to take those two methods, are going to have those two methods, toString and equals. But you would never want to use them because they don't give you the right answer. They give you, I guess it might be useful if you want to know the hex address of it, but normally you wouldn't need to know the hex address. The operating system will just provide some memory. You don't normally. Anyway, they're useless. So therefore, why the heck are they in object? If they're useless methods, why put them there? Because then all the classes, all the objects you make from every possible class will have them in there, in those objects. So that just seems stupid. You have something in every class that you're never going to use. You're going to never want to use it because they don't work properly, right? So if I had a class and I wanted to have a toString method, I'm going to write my own toString method specifically for that class. Same thing with equals. If I have an A object, an A class, and I want to be able to compare two A objects for equality, I'm going to write my own equals method. And it'll be right there in the A class definition, right? And that one would then override the toString and the equals it inherits for objects. But it would make sense that you don't even have those in there, so it doesn't have to override anything, right? All right. Okay, now here in Class A, we're defining a toString method specifically for Class A. So in this class, we only have one data item, the instance variable x, and the toString method just returns that value in the form of a string. But it also, we're a little fancy here, we're concatenating in front of it a label x equals. However, there is something interesting about this that we haven't seen before is protected. Now, let's say instead of protected, you would have private, right? You have private. Then any subclass of A would not be able to access directly X. Private means it can only be accessed from within the A class. However, if you say protected, then it can also be accessed from any subclass. So here I am sort of loosening up. It's not as restrictive as private. I'm loosening up the restrictions so any subclass can directly access X. Protected is an example of a what's called an access specifier. So that's a third one. We've already seen private and public. And then this is a third one, protected. And there's one more that we'll discuss a little bit later on. It's called package. So you got those four: protected, package, public, and private. Here we have B, which is subclass of A. Look at line 11, right? B extends A. And we have, oh, here we have private. So, and we are accessing it, right? Y there. In line 17, we're accessing Y directly, which is legal because toString is in the same class as the instance variable Y. All right, and then I have a toString made specially for this class, right? Because you have an X and Y method, excuse me, an X and Y instance variable, and I think their values are 1 and 2. So this return statement is going to return a long string that consists of X equals, right? Then the value of X converted to a string, and then Y equals concatenated to the value of Y converted to a string. And notice in class B, I am accessing class A, which is in another class, and I can do that because it's protected. If I made it public, I could do it as well, but that public means anything. I don't want anything to be able to access X, but I do want B class to be able to access it, and that's made possible by specifying protected rather than private or public. All right. All right, so now, and here's the main program. If you say a toString, the toString you're invoking is the one that I defined in the A class, and you'll get out X equals 1. And then if you have a B object and you say b.toString, it will return and be displayed. What that one will override the one that's inherited from object. You'll get X equals 1, Y equals 2. And here's another example of of writing your own toString method. So we have it's the same as the previous one, except now I am now making X private. All right, so I can't access it directly from a subclass, so it's now private. And when you call this toString, it's going to return X equals whatever the value of X is, which is going to be 1. It's going to return a string in that form. All right. Okay, here we have the B class, and it has its own toString method. And if you look at line 17, there's the return statement that's going to return a string that shows the data currently in the B object, which includes both the Y data and the inherited X data. And you can see on line 17, way over on the right, this toString method is accessing Y directly, which is perfectly legal because it's in the same class as the declaration for Y. So that's okay, even though Y is private. Now, we also have on line 17 this sort of weird looking thing, super.toString. So what's that all about? Well, you recall that from the previous slide that the A class has its own special toString method, and that toString method is going to return X equals whatever X equals in string form. Okay. Now, by saying super.toString, that indicates we want to call the toString method in the superclass. Okay, a B object actually has two toString methods. It has the one that's inherited from A, and then there's this one that is defined in B. Now, if we just said toString without super, that would be interpreted by the compiler as a call of this toString method. It would be calling itself. And then when it would execute itself, it would again call itself on and on forever. So that's definitely bad. We want to call the inherited toString method. And the way you specify that is to prefix toString with that super period prefix. Now this is the beginning of a program that uses a different approach. In this program in class A, we have an xget method which is public, so it can be called from outside class A. And what it does is it returns the value itself, the int value, which in this case is going to be 1. And then it has its own toString method that will display x equals 1. It won't display it. It will return that string to the caller, and the caller can do whatever it wants with that string. Okay. So we can get x from the subclass. We can access x, but we have to go through get x. We have to go through that method. We can't directly access x because x is private. X can be accessed directly only from within the A class. Now, get x here can do that on line 12 because it's in the same class as the declaration of x. And here we have the class B, which is a subclass of the class A, which we were looking at the previous slide, and it has its own toString method. But notice we're using getX, which is perfectly legal. GetX is in a B object, right? It's inherited, and there isn't one defined at the B. The only XGet you have is the one that you're being inherited. So we're calling that one, and what does that one do? It returns the current value of X, and which then is concatenated to that label, which then is concatenated to the label y equals 1, which is then concatenated to the value in y after it's been converted to string form. So this toString method returns x equals 1, y equals 2. All right, so why is toString and equals in the object class? All right. Doesn't make sense that they're there, but there actually is a very, very, very good reason for those toString and equals methods to be in the object class, even though you would never want to invoke them, execute them, all right? So let's say you have a pointer that's pointing down, right? So let's say little a is an A-level pointer, and B is a subclass of A, and A is pointing down, which is legal, to an object, a B object. And let's say the B object has a toString method, right? The B object, in the B class, you define your own toString, which you see there at the bottom. That's the bottom one, but it also inherits one from object. So if class B has its own toString object, and you inherit one from, and you also inherit one from object class, then a B object will have two toString methods. Okay, and the one that's defined in the B class will override the one that's inherited. So what do you think is going to happen if you invoke the statement that is a period toString parentheses parentheses semicolon? All right. If you say a period toString left parentheses right parentheses semicolon. So which one are you going to call? Well, you're going to call the one that is defined at the B level, the one that you wrote specifically to handle the data, the instance data in the B object. That's the one. Why? Because it's going to override the inherited one. And it works very nicely, right? A dot toString parentheses semicolon. You're going to inherit, right? Right? Everything is good. But say, let's now say there is no toString or equals method in the object class. All right. So then your B object would have just a toString method in it. All right. Would have just a toString method in it. It would have other stuff in inherited A. Let's assume that A doesn't have a toString method either, and object didn't have it. All right. So this object, this B object, would have only one, right? If the A class doesn't have a toString, and if object doesn't have a toString, then the only toString method the B object will have is the one that comes from the definition of toString in the B class. So it would only have that one. Okay, and let's see what would happen if we executed the statement A dot toString left parentheses, right parentheses, semicolon. Well, you're just going to execute that one, right? No, that's wrong. You know why? You're going to get a compile time error because A, assuming A doesn't have its own toString method, a pointer that is of type A is supposed to point to a type A object, and the compiler knows that a type A object doesn't have any toString methods, so it will be illegal. It will be unaware of the fact that A is actually pointing down to a B object, which does have one. You'll get a compile time error. So what you would have to do is you would have to cast the A down to the B level, and then it would compile correctly. But if you have a toString in object, then every object will have a toString method, so you don't need to bother with the class. So it relieves you of the burden, of the very annoying burden of downcast, downcasting uh, pointers in order to invoke a method in an object. So there's a very good reason that these useless toString and equals methods are in object. You never want to use them, but they do serve a very important function. They just make programming a lot easier. You don't have to have the downcast. So we would not need, you could just say a dot toString parentheses semicolon, right? You don't have to say left parentheses cap B right parentheses A dot, you don't have to do that. Okay, before I discuss this slide, I just want to review an important concept. When you get the JDK, the Java Development Kit, which includes the compiler and the interpreter, also includes a whole bunch of predefined classes. And these predefined classes are organized into groups, and each group is called a package. And one of the packages we used was java.util. Remember, we had to import java.util in order to get at array list and random, because those the classes in that package are not automatically available to you. You have to import that package in order to get to those classes. Okay. All right, so now let's, having reviewed the idea of packages, let's look at this slide here. We're declaring 4 variables w, x, y, and z, and for each one I'm specifying a access, what kind of access is allowed. And we're very familiar with private and public, right? Private means you can only access it from within the class in which the w is declared, from within this very class. Public means no restrictions whatsoever, right? You can access it from anywhere. from a subclass or just a completely unrelated class from another package. No restrictions whatsoever. Now, what is the int x? What kind of access that has? Well, if you don't specify private, public, or protected, it defaults to package access. Package access means you can access X directly from within the same class in which X is declared. So within this own class here, you can obviously access X, but you can also access it from any class in the same package as this class. All right, so that's why it's called package access. All right, now what's protected access? So that applies to Y. Y has protected access. So protected access is like package access, but it also allows access of Y from any subclass. All right, so package access is more restrictive than protected access. Package access only allows you to get to X from within this own class or from a class in the same package. Protected means you can directly access Y from this class, its own class, the class in which Y is declared, from any subclass, and from any class in the same package as the specifiers class. All right. So, sometimes you want to use private, sometimes public, sometimes protected, and sometimes int x. Now, typically, I haven't been using package access. I either use private or public. And that's very common when you're creating classes. You want your instance data all private, and you want your methods public so that someone from outside the class can call those public methods, which then in turn access the private instance data. But occasionally you might want to use package access or protected access. All right, so here we have two examples of the beginning of a class definition. One starts with the reserved word public, and one starts with the word class. And that's what I've been using. The second approach is what I've been using. Now, if you say public, then the class has public access. But if you just omit the public, like we're doing in the second example here, then it has package access. And so those are the only two access specifiers that are allowed for a class, either public or you don't say anything, in which case you get package access. Now, one thing you have to understand when you start with public is that the file that contains that class needs to have the same name as the class name. So if you have a file that has public class, you should call that file c.java, and then when you compile it, you're going to get a name which is c.class. Okay, and obviously since the file name has to be equal to the class name if you use public, you can't have two classes in one file, both of which start with the word public. Okay, because that would, each one would have to be the name in the file. You would have two different names, but only one file name. So that would be illegal.